Okay, so we would like to look at question 2 of thermal properties of metal. It's a MCQ question. It's from 2006 paper 1 question 17. So this question actually appeared again in 2011, right? Exactly the same question has appeared. So it is a benefit for students to actually do the MCQ questions, because sometimes in O levels the questions do repeat itself. So let's read this question. All right, this question says that a 2 kilowatt kettle containing boiling water is placed on a balance. It is left there and continues to boil for 5 minutes. The balance reading changes by 0.2 kg. What does this information give you about the value of the specific latent heat of vaporization of water? So some of the keywords you need to know is that the water is already at boiling point when it is placed on the balance, and also that this reading is a change of reading. So this change takes place when the temperature it is boiled for 5 minutes. So first of all, we need to know that energy is transferred between the two entities. The two entities is between the kettle and the water. So this is actually a concept of the principle of conservation of energy, where energy is transferred from one form to another without any loss or any additional energy produced. So the energy produced by the kettle is totally consumed by the water, and as we mentioned just now, it is 0.2 kg of water that is being boiled off, and the water is actually already at boiling point, so no energy is required to raise any more temperature. So the only energy absorbed is only for latent heat. Alright, so because of that, we can simplify the equation into two parts. The first one is that energy produced by the kettle is in the form of energy equal to power times time, while that of the water is mass times the specific latent heat of vaporization. So there's no energy required to raise the temperature of the water, as the water is already at boiling point. So when you put the two equations together, you'll get this. Alright, remember that 2 kilowatt need to convert to watts, so it's multiplied by 1000, while the time was multiplied by 60 seconds. So when you work out, you get 3 million joules per kg. So the answer to the question is D. So this one will also answer question for 2011 paper 1 question 19, which has exactly the same question. Alright.